Hi everyone, welcome back to the channel. Today I thought I'd do something a little bit different. I found another one of these Volt-Ohmmeters by Kyoritsu online for about 30 bucks. And it looked online, the photo looked to be pretty decent, but what they didn't show is that this glass is off. It's broken over there, so that's a bit bad, but still I reckon it's not in bad shape. But what I want to do in this video is just give you a pointer as to how you could get started in electronic as a hobbyist. Because picking up a little thing like this, like I say, it costs you 25, 20, 30 bucks, depending on what you find, you know. And it's actually not a very big, complicated electronic device, but it's very useful if you can get it working properly, and you know, it becomes a useful part of your workshop. And it's a nice way to launch into it because there's not a whole lot of electronics on the inside of it. It's relatively easy to troubleshoot and to repair and to calibrate as well. And once you've done that, you've got a really useful tool for your workshop. So this is a suggestion from me as to how you might want to get started in electronics, is by restoring a nice old Volt-Ohmmeter. It could be a tube ohmmeter, like a vacuum tube voltmeter, or it could be a FET voltmeter, but these are very good quality, and hopefully we're going to discover this together. We're going to hopefully we're going to get this thing restored, up and running and looking good, and using very minimal tools. Over here, cheap little tool set that you buy from one of those cheap stores, you know, costs, I don't know, 10-15 bucks for the tool set. But inside of here, you pretty much have everything you need to get jobs done. You've got a, you know, Allen keys, a cutter, long nose plier, hammer, pliers, different sized bits, and even a little socket set and some wrenches. So you can pretty much do just about anything you need to do just using this little set here. So that's what we're going to be about doing today. And to get started, I've got myself a little soapy rag, and I'm just going to give it a wipe down. Now I can't film and do that, but of course it's just a soapy rag. It's not particularly wet, but it'll be enough to get all the years of grime and dirt off of the thing and get it looking a little better. So let's start with that. Right, so I've given it a wipe with the soapy rag. You can see there's still a little bit of soapiness on the meter. So now with another rag, I'm just going to give it a dry off, and then we'll get a look at how it looks. Right, so just having given it a wash with a bit of soapy water and a rub down, it's already looking just a whole lot better. A little bit of detail still needs to be done over here, but it's pretty much looking a whole lot better. I'll touch it up again now with my rag. There it is. But now we can have a quick look at what's going on with the meter. First thing I notice is that the needle is not set at 0. Now these meters have this little adjuster over here, which should normally set the 0 position of the needle. So that's the thing. Sorry for the shaky camera work, but once again I'm multitasking with my hands. But let's see if we can use a screwdriver and set that needle down to 0. So what I'm going to do is just with this, I mean it's just a little screwdriver bit, but I can get it in there and see if I can turn this. It's having no effect there. It's going the other direction, but not allowing it to go back down. And I get a feeling that the little stud that goes into that needle over there is not engaged correctly. This happens from time to time with these things, and it's an easy fix. Now, one way to know if your meter is going to be all right is to give it a shake, and you see that the needle will move and it's a little bit dampened, and that's a good sign. It does move if you give it a shake, but it moves sort of in a dampened fashion, telling you that the meter is actually not in such a bad state. Next thing I want to do is just check the functionality of the switches. So moving my switches around, they all select inside of the normal ranges. This knob's a bit loose, but it's just the knob, it's not the switch. The switch is functioning normally. So that's great. My range switch is functioning normally, just the knob a little bit loose. I'll see if I can sort that out. And then the switch, the mode selector, that's nice and tight. So what we have is a mode selector for, on this one, plus DC volts, negative DC volts, AC volts, plus DC amps, AC amps, and ohms. And they're color-coded so you can also see the ranges in which the ohms and the volts scales and the amp scales operate. Then down here we have, what is that? That is a 0 adjust for the meter. And we also have an ohms adjust, which you will adjust it for maximum or infinite ohms indication on the ohm scale at the end over here. So those also both feel quite normal. And then of course we have our 2 meter lead connections. Flipping the unit over, we've got some access screws to remove the back panel. And then we have these pull studs, which will release the back door. Okay, so I've got the back panel off. Just a matter of pulling on these 2 little studs. They were in there. Pulling them on, lifting the back panel. And I can get to the battery. There's a clip here for a, what's that, a C-cell battery. Yep, C-cell. 1 C-cell for the ohm meter. And then it needs 2 9-volt batteries in these holes down here and down in here. So I'm going to connect those up, and then we're going to get a look and see how that looks. Right, so my 3 batteries are in, and I can put this back panel back on. It goes on pretty easy. Normally, famous last words when you're trying to do it with one hand. There we go, push that on, push in those 2 little knobbies, and I can flip it over and see what happens when I switch it on. And I want to select it to ohms to see if the needle goes up to the top of the ohm scale, and it does not. So this is a bad sign. Normally on ohms I would have liked to see that needle go up to the infinity position over there, and it has not done it. So now we need to open up and investigate what's going on. So I'll turn the meter back off. Actually, before I do that, I have an external 9-volt connection over here. And I'm going to connect an external power supply, there it is in that box over there, to that, because maybe it's a battery clip that is not connected properly. And that 9-volt power supply might just do the job for me. So let's try that quickly. Right, so I've got external power connected, and it's in, but I must say, turning it up and down, I get no movement on that needle. Things are looking worse. There could just be one other thing. I might have a polarity issue here, because this can connect up 2 ways. I've got to try it with the other polarity as well. So let's give that a try. Alright, so even with the polarity reversed, I'm getting nothing. So that does mean that there's some kind of an electronic problem with this meter. So I'm going to have to get it open and see what I can see inside. I'm going to just do a cursory visual inspection first. So let's get in there. Alright, 2 screws later and the back panel is off and I'm inside. And I discovered a very simple thing. Over here on the front of this meter, where the 2 probe leads go in, on the positive probe actually passes through. Hang on, that's not the positive, that's the negative probe. Sorry, the light's a bit dark here, but the negative probe passes through and it makes contact with this switch. And what I did was I turned it over, back looking face up again, and operated that switch with my finger, and this happened. Oh, where's the switch? Now I can't reach the switch. Come on, you can do it. Oh, that way. I was pushing the wrong way, sorry. So there's the meter working as it should. So I'm in the ohms range. So it's that switch that needs to be actuated by inserting the lead of a meter to start the system working. And I guess that's just to save power on the system when it's working on battery. So that was just all the problem that there was. The next thing that needs to be done is I need to get this glass cover off so that I can try and sort out what's going on with that needle. So that's next. Alright, so I just had to loosen 2 nuts on these 2 studs over here. There are the nuts back there somewhere, hiding away. Each has its own washer. And then these 2 long offset posts, they were on there and on the other side. And I think that's enough now to loosen up my face plate. And I need to do this very carefully because I think it does. It loosens the entire face plate, which I do need to do so that I can get to the clips. And I think there's probably a bit of clear tape that ensures that the glass cover stays in place. But I'm going to have to just get that lifted off. And once again, I can't do it while you watch. Sorry, I would like to do that, but I just don't have the equipment with me here. And once that's open, we can get underneath here and see what's going on with my needle. Because when it's at rest, when this is all switched off, I should have that needle down at 0. So that's what we're trying to clear now. Right, I've managed to get the glass cover off. And now the needle movement is exposed, and it's as I suspected. This is where you adjust the 0 point or the rest point of the needle. But at the moment, because it's had its butt kicked once or twice, it's not able to do that, and this over here is in the wrong place. So now what I'm going to do is I'm going to use this screwdriver to set that needle. And you'll see that now I can actually bring it down to 0. And I've got to do it from above so that my parallax error is removed. And you'll notice this meter actually has a mirror scale. And the mirror is behind the needle there to remove parallax error. So there it is set now for 0 parallax. Okay, if you sit the needle right so that it's over the mirror, you see it's exactly on 0. So now when I turn it on, well, I've set it to battery, and then when I push in on my switch, runs up to not quite infinity ohms. So I'm going to have to just crank this little knob here a little bit, see how that goes. That's pretty close, huh? A little bit more. Okay, I'm going to try and do that again by putting the phone down. Let me try one more time. I think I appear to be getting there anyway. Yeah, it's getting closer. So you see, I'm just keeping on adjusting this little knob. Now normally, this normally would be done quite easily just by having a probe in place and then turning on the knob, and then you'll see that meter move, that 0 setting move. Okay, this is a 0 adjust, not an ohms adjust. Let me just try this 0 adjust knob there. Yeah, it's not doing anything. All right, no problem. No problem. But the meter might need a little bit of calibration. We'll have to see that. So if I now go to my voltage, 0 adjust is not doing anything there. Negative DC volts seems to be pretty steady there, but I must switch it on. I keep forgetting to switch it on in the voltage range. You see, that's the DC volts. Also goes up there. That's kind of strange. All right. Oh, hang on. On. That's the battery check that I've been doing. I've been doing the battery check. What a fool. So now I'm in the DC volts range, and my zero just needs to be set. There we go. Now it's, you see it went to negative there. So I'm actually setting now my 0 volt reading in DC volts. Come on. Be nice if I could jam something in there, then you can watch how I'm doing this. But anyway, we'll get there. That's pretty much it. Not quite, but very close. You can see it's very finicky. However, the good news is that my meter's working. That's really the good news. Okay, that's really close to 0. I wonder what it's like in here. Yeah, okay. But you can see the idea. Use your 0 adjust with your meter activated, and then maybe I can try and push in something like one of these, just to persuade the meter to work. Let's try that. Just hold on a second. Right, so I managed to wedge a bit of cardboard onto that micro switch to keep it made, and now it's a simple matter to adjust my 0 point on my voltage scale. There it is. Now when I select the ohms scale, right, it runs up to my infinity position, and I can adjust my infinity right there. So now the meter is set up to be used. Let me just switch it off again. Make sure that the 0 point is still zeroed. All right, it maybe can come a little down. Maybe can come a little down. Let's try that. Let me get you back in the picture. That might be a little too down. That's pretty good. That is pretty good. So that now when I turn my meter back on, I'm in infinity ohms, and let me first go to volts. Set that, check that 0 is still good. It's a little bit off. And then my ohms, that's really good. Sorry, I keep drifting off. So now the meter is pretty much set up for use. Now you can see that my adjustment lever over here for the 0 adjustment of the meter is pretty much in the middle. So what I want to do here is I want to just check. You can see that this guy has a little stud on there, if it'll focus. Come on, you focus. There you go. See that little stud? So I need that little stud to be at the 6 o'clock position, which it's not at the moment. Hard to see, but it's not. It's more like at the 1 o'clock position, because remember, this is upside down. At the 1 o'clock position. So I'm going to turn on the screw so that that stud is at the 6 o'clock position. So when I put the glass back on, then it'll mate with that adjustment over there. So that's next. I've adjusted that little stud to that 6 o'clock position. So now it should mate very nicely with that slot when I close this up. So I'm just going to try and do this while you look, and we'll see if that's going to go into position. That's clipped on. Looks like it's down. So now if I take it out of ohms, put it back to volts, it should go back to 0. Now that has changed a little bit, but I can, once again, set the 0 point, and if I turn the power off, let's see where it goes. Yep, that's sitting at 0. That's the battery check. The battery's in great shape. And power is on. Meter works. Now, all that remains is to actually see if the meter, how well it's calibrated, that is. And in order to do that, I need a set of meter probes. So I pulled out my piece of cardboard. I actually have some probes. I just got to go and get them. we'll plug them in and we'll connect them to my remaining 1.5 volt battery, which will be able to tell us just how well calibrated this meter is. So that's the next step for that. Alright, so I'm using a digital voltmeter, very cheap one, cost me like €4 at one of these cheap shops, to test the voltage of the battery. So I have a baseline reference, and it is 1.6 volts, okay, 1602 millivolts, 1.6 volts. So now when I do the test on my other meter, that's what I'm going to look to see how close that meter reads to 1.6. Just to show you, that's that little cheap meter there next to the one that we are working on. Now, this little cheap meter works really fine. It's so much better than I thought it would be at this stupid price. It even has a transistor tester on it, which again is testimony to the fact that you can get started in the electronics hobby really at a very, very low budget. Really, I've got this meter, it cost me €4 or €5. This tool set was probably about 12, maybe less, 9, I don't remember, but it'll definitely well below 20. And of course, I got my first project, that cost me 29, and I'm away. Now, I haven't needed a soldering iron yet, but even a soldering iron, you can get them pretty cheap from places like Lidl. And I actually think I'm going to pick one up from Lidl, because sometimes you do need to do some soldering, and you get an iron and some solder with it for really also about 15, 16 bucks. And you know, you're pretty much on your way to get started in electronics with just these few simple tools. And look at this, I've gotten this project working with very little indeed. So hold on, let's get these leads into this meter and see how it performs. All right, after much balancing and holding, the probes are connected to the battery. And now you can get a good look. I'm on the 3 volts scale, DC volts plus. And look at that voltage reading, 1.6 volts with no change. This thing is deadly accurate. Now, the way these things are made is, of course, they've got precision resistors inside, so you can be pretty sure that that accuracy is going to be repeated throughout all of the voltage ranges. And because the voltage reads correctly, the resistance, the ohm scales will also read correctly. This meter is working. It's fine. The only thing that I'm going to need to do is find a bit of acrylic to close up this gap on the side over here, and flatten that out, glue it in place, and I will have a really great, highly accurate FET Volt-Ohmmeters. Volt-Ohmmeter, listen to me. Now, what's the importance, or what's the significance of having a FET Volt-Ohmmeter or a VTVM? Well, they have an extremely high input impedance. So when you're measuring circuits that have a high impedance, you don't load the circuit. The meter is almost invisible to the circuit, so your voltage readings are extremely accurate. And I happen to know that these Kyoritsu meters, this is a K-200, they are that good. They are so, so good. Anyway, thanks for watching. Now, I hope you get an idea of how quick and easy it is to get into the hobby of electronics and have a little fun project to do with relatively little equipment, but end up with a product that is going to be useful to you for years to come. So before I sign off, let me close up and show you the finished product. So there it is in all its glory, voltmeter. Now I put the I reset the thing, and I'm going to have to do it again. As you can see, it's no longer at rest. I think it's got to do with maybe a bit of static on the shield here. I'm not so sure. So that's going to need a quick little turn to get it right. but I'll do that off camera once it's done. You know how to do it. I've got that little stud now set up correctly, and I can adjust it in here. Probably even demonstrate my fingernail, but I might just end up hurting my fingernail, so I won't go that far. But there it is. This Volt-Ohmmeter is working really beautifully, and I'm really happy with the result. It needs a little bit further cleanup, but it's already looking so good, you know. 30 bucks, and like I say, the only thing left to do is this gap down here. That's going to have to be covered up. It's going to get a bit of clear acrylic, flatten this surface off here so it's nice and straight, and I'll glue an acrylic strip on there, trim it so that it's hardly visible. And then it seals any dust from getting into the meter, and it'll work just fine. You can see a little bit of cleanup on the knobs. And that one I think is also a little bit loose. Tighten that up, and we'll have a working meter. Not bad for a 20-minute video, because that's literally how long it took to get this done. So thanks for watching. Hope to see you again soon. I'll try not to take too long before my next video. And I'll show you this meter in action when I put it on my bench in a future video. Bye for now.